In this lesson, we're going to look at those drive-through service times and the frequency distribution from the previous section to create the associated graphs. We'll do them by hand and then do them using technology. This particular frequency distribution is slightly different than the one we created by hand completely. If you recall, when we created ours by hand, we started our frequency distribution at 83 instead of 75. And we had a class width of 46. This table was created starting at 75 with a class width of 50. So starting a little bit lower than the lowest value in our data set, we make our class width a little bit wider so that we can make sure we capture all of the values in our data set. Again, it's just a different way to create a frequency distribution from exactly the same data. The overall shape should be the same, or should be very similar, I should say. We have 5 classes. We're just shifting the values around in our 5 classes compared to the previous one we did by hand. Okay, so let's start out and create our histogram and our frequency polygon, and then to create our ogive, we'll need that cumulative frequency distribution from this frequency distribution. So here we go. The first step that I'm going to do is create my axes. Now by hand, our frequency distribution would use the class boundaries. So I'm going to demonstrate that here. But remember what I said about technology in a previous lesson? Technology won't allow us to do this. That's okay. As long as our graph is clearly labeled with our axes and our title, if it's easy to read, that's the intent. But I will demonstrate this for you so that you have a frame of reference on how to do it. So our lower boundary for 75 would be 74.5. Between the two classes would be 124.5, 174.5, 224.5, 274.5, and our last one, 324.5. I try to make them evenly spaced as best I can. That is important. We don't want one bar to be much wider or much narrower than the others. And then we can create our y-axis, our vertical axis. I'm going to make my marks by 2s. We want to make sure on the y-axis, again, evenly spaced, and every mark indicates the same amount. So 2, 4, 6. It's not going to be perfect by hand. That's understandable. We want it close. So then we can draw our heights. I'm going to do mine in a different color. Let's use green. So 75 to 124 goes to 11. 125 to 174 goes all the way up to 24. 175 to 224 goes to 10. 225 to 274 is 3. And then the last class is 2. And we could color them in, but that takes a lot of time. So I'm just going to leave them empty. And there we have our drive-through service times. I'll put some labels on there, our title, and there we have our histogram. To create our frequency polygon, you can do it below. I'm going to do mine to the side so that I have this histogram right here next to me. So to create the frequency polygon, we can have the same y-axis. And this time along the x-axis, we would actually create the midpoints of our class. To create the midpoints, we're going to take our boundaries, 74.5 plus 124.5 is going to give us 199. Divide by 2, we get 99.5. We're going to leave a little bit of room so we can anchor that frequency distribution to the x-axis. We have 99.5. Add 50 to get the next one. And we can label the beginning or the end or not. To me, the beginning and the end don't really matter. So we can label those or not. And then our heights are the frequency values. So at 99.5, that's our first class. We had 11. 49.5 we're going to anchor. 149.5 is our second class. That one goes all the way up to 24. 199.5 is our third class. That one was at 10. 249.5 is our fourth class. That one was at 3. 299.5 is our last class at 2, and then we anchor it again. And then it's a matter of drawing straight lines to connect the dots. And there's our frequency polygon. You can see the overall shape of both of these is the same. It looks like we have a really quick up and then a very slow down. So the quick up, slow down, that's like our right skewed graph being pushed from the right. So we would say in both of these cases, this is a right skewed distribution. To create our ogive, we need a cumulative frequency distribution. So let's do that. We have our table here, and we'll set up our table, and I have my cumulative frequency. You have the table, so I'm going to be referring to that same table. Less than 125 is 11. 11 plus 24 would give us 35. 35 plus 10 would give us 45. 45 plus 3 is 48, and 48 plus 2 will give us 50. Remember, for the cumulative, we're always adding the previous value in our cumulative frequency table with the value in our frequency distribution table. And so here we have our cumulative frequency distribution. To create our ogive, we start out with our axes. We would use class boundaries to label our ogive, but again, that might be difficult using technology, so technology could be different. And our cumulative frequency will be a little bit different on the labeling because we do have to go all the way up to 50 for our ogive. We'll start at 0. 125 is at 11. 174.5, that'll get us to 35. 224.5 gets us to 45. 274 only adds 3 more, and 324 only adds 2 more. And so our ogive, very tiny increase at the end. It might even look almost like a flat line. And that's our ogive. All of these I'll recreate using Google and Excel so that you can see how to create each one of them. I'm going to input the frequency distribution table, and I'll show you again how to create the cumulative frequency table from the frequency distribution, and we'll create all 3 of these charts in that next lesson using technology.